Hey, so something that popped up a lot in my answers on the bonding and the gas and molecular forces quiz was the idea of branching. So what I've seen is that I need to go in and I need to clarify what exactly branching is. Okay, so with branching, so what I saw is that many of you took that if an atom was bound to a greater number of atoms, that meant there was a higher degree of branching. So for instance, this sulfur or this molecule would be more branched than this molecule because this sulfur is bound to 3 things, whereas this sulfur is bound to 6 things. So that's not actually what is meant by branching. So if you see a molecule where, like this, it's not branching. Branching only comes into play in one very specific special case. And that is when you have a carbon chain, okay? And specifically, we're really only going to see branching come into play when you have multiple carbons that are strung together, and you have to have actually greater than 4 carbons in a row. So for example, over here on the left, we have butane. Alrighty, so 1, 2, 3, 4 carbons. Those are in a line. Over here, we have isobutene. And what that is we have 1, 2, 3 carbons in a line. Alrighty, so you have 3 carbons in a line. And then we have 1 carbon coming off. So that is an example of branching because you have a carbon trunk and then a carbon leaf coming off it. And so in this case, this molecule, this is an example of linearity, so that chain is linear, so it has more potential to make IMF contact, specifically London dispersion forces, whereas this one, it would be harder and fewer London dispersion forces will be made. But we only see branching come into play when you have a long string or chain of carbons.